Hi everyone, hope you had a nice weekend. And last week we saw about binary phase shift keying. That is one of the digital modulation techniques. We saw what are its basis function, what are its signals. We saw the constellation diagram. We saw the probability of error. We draw the receiver block diagram, transmitter block diagram, as well as the receiver block diagram. So today we will see about another digital modulation technique called Qpsk or quadri-phase shift keying. Quadri-phase shift keying, Qpsk. So kindly mark your attendance in the live chat. So please write your university register number and your name in the live chat so that I can mark the attendance. So I'm waiting for your attendance. Okay, you keep typing and let me start the class. Okay, let me share the screen for you. So we are going to learn about quadri phase shift keying or QPSK. Okay, so from the word itself, quad means four. Okay, so uh, we can get a hint that there are four. Okay, let us go means so binary means two. So quad means there are four. It is again phase shift keying. So there are actually four signals. Okay, in QPSK. Or rather I can say there are four symbols in QPSK, and it is how are these signals represented? They will be represented by phase shift keying. So they are represented by four equally spaced phase shifts. So we are using pi by 4, 3 pi by 4, 5 pi by 4, and 7 pi by 4. So four different phases we are going to use. And so how will we write our signal Si of t? We will write our Si of t as equal to square root of 2e by t into cos 2 pi fct plus 2i minus 1 into pi by 4, where I can take value 1, 2, 3 and 4. So when you substitute the value 1, you see it is 2 into 1 minus 1. So it is pi by 4. When it is 2, you can see 2 into 2 minus 1. It is 3 into pi by 4. When it is substituted 3, we get 2 into 3 minus pi by 4. That is 6 minus 1. That is 5 pi by 4. And when it is 4, you get 4 into 2, 8 minus 1. That is 7 pi by 4. So we are going to modulate it using four signals or using a signal cos 2 pi fct plus pi by 4 or cos 2 pi fct plus 3 pi by 4 or cos 2 pi fct plus 5 pi by 4 or cos 2 pi fct plus 7 pi by 4. Let us see the other terms. The other term is E. Remember, E is the energy per symbol. So earlier case in BPSK, bit and symbol was the same, but here we find that the bit and symbol is not the same. We will see soon why it is so. So here E is the energy per symbol and T is the time for, or it I can write it is a simple period. Capital T is the simple period. Capital T is a simple period. So this is about the signals. Now we will see the signal space representation of our Qpsk signal. So our topic is signal space representation of Qpsk signals. So we can write, hope you remember, we can write cos A plus B as cos A, cos B minus sin A, sin B. So I am going to apply this formula for this signal Si of t. Okay, let's see how it comes. So applying this on our previous function Si of t, we can write Si of t as equal to square root of 2e by t into cos 2 pi fct into cos 2i minus 1, I'll put it in one bracket, then pi by 4 minus 2e by t, again the same coefficient, then you will have sine 2 pi fct into sine 2i minus 1 into pi by 4. Now I want you to find the orthonormal basis functions using Gram-Schmidt orthogonalization procedure. You can do it as a homework. I will give you as a homework. But what will we get as our basis functions? We will get the basis function phi1 of t is equal to square root of 2 by t into cos 2 pi fct, and phi2 of t is equal to square root of 2 by t into sine 2 pi fct. So basically it is this term and this term, this part and this part. Okay, what you have to do is substitute I equal to 1, I equal to 2, I equal to 3, I equal to 4. So you get 4 signals. And then for that you apply the orthonormal basis, orthogonalization, Gram-Schmidt orthogonalization procedure. Then you will get this basis functions. So this basis function, it is square root of 2 by t into cos 2 pi fct. Another will be square root of 2 by t. Sorry, should not. This is 2. 2 into, so 2 by t into sine 2 pi fct. Therefore, we can write our Si of t is equal to square root of e into cos 2i minus 1 into pi by 4 into phi1 of t, our basis function, minus square root of e into sine of 2i minus 1, 2i minus 1 into pi by 4 into pi 2 of t. So I have written my signal in terms of the basis functions. Now there are four possibilities, right? So I can write my signal coefficients as a matrix also. Signal points can mark as a vector. Square root of e into cos 2i minus 1 to pi by 4 and minus square root of e sine of 2i minus 1 to pi by 4, where I is equal to 1, 2, 3 and 4. And before proceeding further, let me also tell that, okay, when we wrote this as the equation of our Qpsk signal, we told about E, it is energy of the symbol, T is the symbol period. What about Fc? The conditions for Fc, remember, Fc will be a frequency higher than the symbol frequency, and remember Fc will be we imposed a condition. The symbol period will be an integral multiple of Fc. So we will follow that condition also. The symbol period will be an integral multiple of 1 by Fc. Remember that. This also you have to remember. Now let us substitute these values and let us see what are the for various values, what are the various values of I, what are the values of the signal vector. So we will draw as a tabular column. First we will write what is the value of I. So when I equal to 1, remember our phase is pi by 4, and what is our signal points? It is actually cos 2i minus 1. So cos pi by 4, which is equal to cos 45 degree 1 by root 2. And remember the other value is minus sine 2i minus 1 into pi by 4, I equal to 1. So sine minus sine pi by 4, which is equal to minus 1 by root 2. So remember this is the value of I. First column is the value of I, second column is the value of phase, and first component and second component. Okay, when I equal to 2, you have 3 pi by 4. Remember 2i minus 1 pi by 4. So you have cos 3 pi by 4 and minus sine 3 pi by 4. So 3 pi by 4 is actually in the second quadrant. So in second quadrant cos is negative. So we will have 1 minus 1 by root 2. And in the second quadrant sine is positive. So sine 3 pi by 4 എന്ന് പറയുന്നത് 1 by root 2 ആയിരിക്കും. So both of them together will give you minus 1 by root 2. And when I equal to 3, we have 5 pi by 4. So it is cos 5 pi by 4 and minus sine 5 pi by 4. So 5 pi by 4 will come in the third quadrant. Third quadrant cos is negative. So again this is 1 by root 2. And sine is in the third quadrant is negative. So negative plus negative will be 1 by root 2. Negative to negative will be 1 by root 2. And when I is equal to 4, okay, it is not visible. I am not able to write properly. So it will be 7 pi by 4. So what will be the values? Cos 7 pi by 4 and minus sine 7 pi by 4. The fourth quadrant cos is positive, so it will be 1 by root 2. I am writing only the final answer. Please write the intermediate step also. I am not able to write it. And sign will be negative. So negative and negative will be positive. It will be 1 by root 2 here. Okay, so please write the value. So when I equal to 1, I can write my points as root t by 2 and minus root t by 2. When I is equal to 2, I can write it as minus root t by 2 and minus root t by 2, right? When I equal to 3, I can write it as minus root t by 2 and plus root t by 2. And when I is equal to 4, I can write it as plus root t by 2 and plus, both are plus root t by 2. So now I can draw the constellation diagram. So in my constellation diagram, there are two basis functions. Phi 1 of t and phi 2 of t. So let's take the first point. It is square root of e by 2 and minus square root of e by 2. So that will be this point, right? Okay, I'm taking this to be root. So this is going to be the first point. That is S1 of t. Because it is plus root t by 2 in phi 1 axis and minus root t by 2 in the phi 2 axis. Now second point is minus root t by 2 minus root t by 2. So that will be this point, right? S2 of t. Because both are minus root t by 2 minus root t by 2. Now third I equal to 3, it is minus root t by 2 and plus root t by 2. So it is in the second quadrant. It is this point S3 of t. And the fourth one is plus root t by 2 plus root t by 2. It is this point which is S4 of t. So this is our constellation diagram. Please draw it correctly. My lines are not straight, so kindly excuse me. And you can see mark the boundary points also, right? Because we know what is the boundary. It will be the perpendicular bisector of the line joining the 2 points. So S1 and S2, we will connect it and draw the perpendicular bisector. It will be the x-axis or the phi 1 axis. S4 and S3, it is phi 2. S3 and S2, perpendicular bisector will be phi 1 axis. So this axis itself acts as the boundary. So any point, so we have, as we described earlier, we have 4 regions, right? We have Z1, Z2, we have Z3, and we have Z4. So if the received symbol lies in Z1, we will say that the symbol transmitted is S1. If the received symbol lies in the region Z2, we will say that the symbol transmitted is S2 of t. If the received signal lies in the region Z3, we will say that the symbol transmitted is S3 of t. And similarly, if the received signal lies in Z4, we will say that the transmitted signal is S4 of t. So that is one thing. Now one more thing I want to bring to your focus is, see, in binary PSK. BPSK we had two symbols. So the binary symbols were 0 and 1. Now here we have four symbols. Okay, so what is the, so we have to consist of four symbols. So four symbols means we can include 2 bits. So each point will be representing 2 bits of data. Okay, so Z1 S1 of t will be representing the symbol 1 0, because there are 4 symbols, we can use 2 bits. So S1 of t will represent 1 0. Actually you get it from even you can identify it from these values. See, this is a positive value, this is a negative value. So instead of negative value we substitute 0, instead of positive value we substitute 1, so we get 1 0. S2 of t, it is minus minus, so it represents 0 0 in the binary. When we transmit 0 0, correspondingly S2 of t is transmitted. S2 of t means a signal with phase 3 pi by 4, and correspondingly the coordinates will be minus square root of e by 2 and minus square root of e by 2. Now S3 of t, you see, it is negative, it's negative, and here it is positive. So it is the symbol transmitted is 0 1. So when 0 1 has to be transmitted, we transmit the signal S3 of t. And S4 both are positive, so it is representing 1 1. So the symbol that is what we are going to do is we are going to take two symbols, 2 bits together. 2 bits form a symbol, and for each symbol you are going to transmit a corresponding signal, S1 of t, S2 of t, S3 of t, or S4 of t. And this is received by the receiver and it is decoded, and we will find which region it falls, and then we will say that okay, since it falls on this region, this symbol or this signal is transmitted. See, now I have drawn you the waveforms also, you can see. So the data to be transmitted is actually 0 1 1 0 1 0 0 0. This is the data to be transmitted. So in QPSK we group it into 2 bits. So this is the first set of bit, this is the second set of bits, this is the third set of bits, and this is the fourth set of bits. So this is symbol 1. This is the first symbol that has to be transmitted. This is the second symbol that has to be transmitted. This is the third. My pen is not clear, sorry for that. And this is the fourth. So you can see it is called a die bit because we are going to group it together as one die bit. So die bit 0 1, die bit 1 0, die bit 1 0, and die bit 0 0. And remember, phi 1 of t and phi 2 of t. Phi 1 of t is a cos waveform, phi 2 of t is a sine waveform. And you can see for 0 1 we will transmit S3 of t, and for 1 0 we will transmit S1 of t. Next is again 1 0, so we will transmit S1 of t, and then it is 0 0, so we will transmit S2 of t. So correspondingly we are going to transmit S3 of t, S2 of t, S2 of t, and then this is S4. Sorry, I am entirely wrong. Did I make a mistake? S3 of t is S1 of t. 1 0 is S1 of t, sorry. S3 of t, then we transmit S1 of t, again S1 of t, and then S2 of t. So you can see the phase changes. So S3 of t, no, when S3 of t is transmitted, we are going to transmit square root of e into cos pi by 4. S3 of t, it is 0, 1, the third case. So we are going to transmit cos pi by 4, phi pi by 4 and minus sin pi by 4. So accordingly, we have drawn this waveforms, this waveform and this waveform. Then we are sending S1 of t. So for the next symbol period, we are going to transmit S1 of t. For the next symbol period, we are going to transmit again S1 of t. Because both are the same, no, there's no phase shift. We cannot identify any phase shift here. Then we are going to send S2 of t. So there will be a phase shift. So here also we cannot identify any phase shift because the same signal is being transmitted for two symbol periods. So here you can see a phase change, and here you can see a, okay, here you are not able to see a phase change. Okay, I will look into that why there is no phase change. So this is how we are going to transmit, and this there are, so you have, this is about on the basis function phi 1 of t. First one is about the basis function phi 1 of t, and second one is on the basis of phi 2 of t. So we have these two waveforms, we are going to combine it together. This is because we have this expansion. Expansion we are right. This is actually the symbol. So we have expanded it and written in terms of two components. So we are going to combine it and going to transmit. Okay. Now one more thing is, I want you to notice this. See, what are the symbol die bits? So this corresponds to the die bit 1 0. This corresponds to die bit 0 0. This corresponds to die bit 0 1, and this corresponds to 1 1. So if you look into this order, you can see that this follows the gray code. So what is gray code? Hope you remember what you studied in digital electronics. Gray code means the adjacent numbers will be differed by 1 bit. That is gray coded representation. So 1 0 and 0 0, these are the adjacent ones. See, they differ by 1 bit by the MSB. Second consecutive 0 0 and 0 1. If you see these two, we can see it differs by 1 bit. LSB is just changing. If you see this two, 0 1 1 1, so it differs by MSB. And even this one and this one, you see, no, you can see it differs by the LSB. So in gray, we are going to represent the die bits using gray code representation, because then the adjacent bits will differ by 1. Okay, so this is about Qpsk, quadri phase shift keying. Please go through this material 1 or 2 times. Really understand. So we saw the Qpsk signal, the signal phase, signal space representation. We found the signal vector. We substituted the values. We found the individual points representing each of the signals. We marked it in the constellation diagram. We also saw the symbols, 4 symbols, which is representing the 4 signals, and we draw the waveforms also. So please go through this material 1 or 2 more times. If you have doubts, please ask. We will discuss in the next class. Thank you.